Welcome back, students. So yet here we are with another topic on the motion chapter, that is equations of motion. Okay. So I hope everybody has gone through what we have discussed earlier because that will help us in this chapter. Okay. So here we'll discuss about, we already have, talked about the distance, speed, velocity, acceleration and everything. Now we'll talk about when an object is moving with an, a uniform motion. Let me just take the annotate. Yeah. Okay. So in uniform acceleration, meaning its acceleration remains constant. It's not changing. Like you're not constantly changing the speed. Okay. Not speed, acceleration. You're not providing acceleration to your, vehicle all the time. You're not changing it. So if that is not happening, and if the acceleration is uniform throughout the, the session of you moving somewhere or something is in motion, so we can use a set of tools or equations to actually calculate the total displacement, the final distance, and as well as time also, that how much time something will take. So you can predict things. Okay, so that will be something cool, right? You can tell already that what is going to happen in future, like a vehicle is moving, so that vehicle at what time it will reach if it follows a certain pattern. Okay, so by looking at the pattern you can come up with different ideas about that. Okay, so the key things or the key terms which we'll have to know is, the first is u. So I have told you in the previous session that u symbol usually in physics we are going to denote for initial velocity, and the unit of initial velocity would be meter per second. V is the final velocity, that means how much you have changed, right? After that, what velocity you have reached. So that is V. A is the change in the velocity, that means final velocity minus initial velocity upon time. That is your acceleration, right? And S is nothing but displacement, that means the shortest distance covered, and again its unit is m, okay, meter, and time is time. Okay, t is time, and it is going to be seconds. Now how we can use all these and play with these to find one particular thing which is missing from our whole equation. Okay, or if we, for example, we know the initial velocity, the final velocity, the acceleration, and displacement of anything, we'll be able to calculate time. Okay, if we do not know acceleration, we can use initial velocity, final velocity, and displacement and calculate the acceleration. Okay, so that is how we'll do it. Now let's see how exactly that works. Okay, so the first equation is velocity time relation. Here what happens is, if you take, let's say v is equals to u plus at. What is happening here? Basically, this foundational or fundamental equation, you can say, directly links an object's final velocity to its initial velocity, acceleration, and time, over which acceleration requires. It essentially tells us how much an object's velocity changes due to constant acceleration over a given period of time. So for example, let me explain you, don't get confused. So this is your initial velocity, and over a period of time, velocity. Okay, I'm just writing, okay, velocity. Over a period of time, you're putting acceleration to it, uniform acceleration. So there is acceleration, right? And time in a particular time. So if you will be able to solve this, you will get your final velocity. Okay, so this is one formula which can bring out the final velocity for you. So that means, for example, let's take an example. So if a car is there and it's starting from rest. Now, whenever something is starting from rest, it is a trick, you can say, it is a tip, you can say, you have to take u as 0. Because initial velocity is 0, right? It is starting from rest. Suppose I'm stationary here, and suddenly I started moving. So my initial velocity was 0, right? I wasn't moving at all. I was like not in motion, right? So u is equals to 0, you will take, and accelerates at a steady rate of 2 meter per second square and for 5 seconds. So acceleration also, u is equals to 0. Acceleration is equals to 2 meter per second square. And you have given with time also 5 seconds. Now, you can easily calculate the final velocity because 0 was the first initial speed, right? Or velocity to be precise. And then there is acceleration of 2 into time, that is 5. And you have a final velocity of 10 meter per second. Okay, here you can check your answer as well, right? This is the answer. So after 5 seconds, the car's final velocity will reach to 10 meter per second. So first, initially, it was at 0, right? 0, and then started moving. And after 5 seconds, okay, after 5 seconds, it will achieve a velocity of 10 meter per second. That means you have started your car. Okay. Now, the second, you can say equation would be displacement time equation. So here you will be able to calculate the displacement with the help of your initial velocity, your acceleration, and the time. Okay, so this equation helps us to calculate the, like I told you, total displacement of an object. It considers both the distance covered due to initial velocity and the additional distance covered due to its constant acceleration. Now, hear me out, try understanding it. So maybe why my initial velocity is 10 meter per second. Okay, but over the time I have started putting acceleration and now it has increased to 15 meter per second. Okay, so now my displacement would be more than what it was supposed to be before, because earlier I was supposed to cover 10 meter per second, and if I will not change my velocity, it will be again 10 meter per second. Oh, sorry, 10 meter per second, right? So 10, 10, 20, but here 10 plus 15 would be 25. So there is also more distance or displacement is being covered, right? Just because I have accelerated my vehicle. So here you can check out the displacement with the help of initial velocity and what time it has taken, okay, to, achieve that initial velocity plus acceleration, okay, times square. That in that time, how much have you accelerated? Okay, so imagine the same car from the previous example is again starting from 0, okay, initial, okay. Now with an acceleration of, you can say 2 meter per second, the same example we are taking per second square, and time is 5 seconds. Okay, so now using this formula, you can tell how much displacement would be there by that car, how much it will move, okay, in a particular time. So S is equals to UT plus, half AT square. That means U is 0. What is T? T is 5 plus half. How much acceleration is there? 2, right? How much time again? 5 square. Now, can you solve this? You will come up with something as 0 into 5 is 0, right? So let's not consider that. You'll cut it out. You'll get here 1 only. And 5 square, what is the square of 5? That is 25, right? 25 meters. So this is our answer. This much distance is covered by the same car, okay, whose final velocity we calculated earlier. Okay, now coming to the third equation, that is velocity displacement relation. So here you will be able to figure out that how much something is displaced and what will be its velocity. Okay, so there is no involvement of time. Even though the time is not given to you, you will be able to figure out rest of the things. Okay, so here the final velocity squared will be equal to the initial velocity squared plus 2 into acceleration into displacement. Okay, now let's check whether this is, correct or not. Because initial velocity, final velocity, we remember, right? So we'll take the same example again. So let's confirm our previous results. If the car accelerates, so U is equals to 0. Okay, A is equals to, because we have discussed already, I'm not repeating it again. And distance would be 25 from the previous example, which we have taken for the other equation, right? 25 meters, right? Let me just correct it. It's 25 meters. And T we don't need, we don't know. Okay, so leave it. Now V is, let's calculate V here. So our final velocity would be U square plus 2AS. that is 0 square. Again, 0 it will come, right? And 2 into 25, right? So now this will be, you can calculate it as like 0 plus this will be what? 100, right? And 2 into 2 is 4, 4 into 25 is nothing but 100. So now when you will take the root of 100, it will come as, because it's v square, no? So once you are removing the square, you will get under root 100 and it will be 10 meter per second. Clear? So you have calculated the final velocity. For the same example, now let's go back and check whether it was, the final velocity was 10 or not. Because we have taken every value similar, right? So here, see, check. So here in this example, the final velocity, again from this also you calculated it was 10 meter per second. But here you were using time. In that, we were using only distance, not time. Okay, so these are the equations which will help you calculate a lot of things in physics, a lot of distances. So just to summarize everything, you have seen, right? So here the relation is between the final velocity, initial velocity, acceleration, and time. Here it is the relation is among the displacement, initial velocity, acceleration, and time. And in this equation, that is v square is equals to u square plus 2as, it relates the final velocity with the initial velocity, acceleration, and displacement. Okay, you can use it in different cases. For example, to find out the final velocity, when time is known, you can use the first formula. When time is not known, it's unknown, you can use the last formula. For finding out the displacement, when time is known, you can use the second formula. Okay, so I hope you understand, you understood all this. Okay, so this example I have taken, you can try solving this. Okay, because I have already solved a bunch, 3 examples. So you can maybe pause the video, okay, try solving this question and then try checking the answer for it. And again, you can do these questions and comment me that whether you understood or not. Okay, so the question 1 is, a body starts from rest and accelerates at 5 meter per second square for 6 seconds. And what would be its final velocity? That you have to figure out. Then second question is, what is the displacement of the same body for 6 seconds? Same body you have to take from the previous question. Which equation of motion is most suitable to use when the time variable is unknown? So you can go with the third one. Now you have to think what was the third one, okay? Or maybe you can go back in the video and try to figure out, okay? So with this, we are done with this, another topic of motion chapter. And I hope you enjoyed the session. Try commenting all the answers so that I can, reply to you. And check out my Urban Pro profile to learn more. Thank you.